All right, hello, and welcome to the AI Research Roundup. I'm your host, Alex, where we dive into the latest in AI research. Today, we're looking at a paper called FoundationStereo Zero-Shot Stereo Matching, published January 17th, 2025. So, the main idea here is creating a foundation model for stereo depth estimation that performs really well without needing fine-tuning on specific datasets, what they call strong zero-shot generalization. They tackle this by first building a massive, highly realistic synthetic dataset, and then designing some clever network components to boost its robustness and accuracy across different domains. Okay, and speaking of that, large synthetic dataset and the model itself, this next image actually shows the project's GitHub page. It's great to see they've made this public. So, you can find the official code implementation there, along with demo scripts, the pre-trained model weights, and even links to download that massive FSD dataset we just talked about. So it's all there if you want to dig in and experiment with it yourself. Okay, so speaking of the model's capabilities, this first figure really drives home that zero-shot generalization point. What we're seeing here are results on various in-the-wild images, stuff the model likely hasn't seen before. The top row is just the input RGB image, like a keyboard, a sink, a robot arm, a warehouse, and an outdoor scene. Below that, you see the disparity map predicted by FoundationStereo, where color indicates depth. And the bottom row shows the resulting 3D metric point cloud reconstructed from that disparity. It really highlights how well it works across diverse scenarios without needing specific training. Okay, so we talked about the FSD dataset being crucial for that zero-shot performance. This table really puts that dataset into perspective. It compares FSD, which is their dataset, with other popular synthetic datasets like SceneFlow, Tartan, and others across different properties. You can see FSD is just massive. 1 million stereo pairs, compared to, say, only 40,000 for SceneFlow. Plus, it covers more scenarios: indoor, outdoor, driving, uses NVIDIA Omniverse for high realism, and importantly, varies the camera parameters, unlike most others. This scale and diversity really help build that robust generalization. Okay, so building on that discussion of the dataset and zero-shot performance, this figure 2, gives us a look under the hood at the FoundationStereo architecture itself. It shows how it goes from the left and right input images on the left side there to the final disparity map on the right. You can see it uses several components, including a side tuning adapter, which cleverly incorporates knowledge from a pre-trained monocular depth model. Depth anything V2 to get better geometric priors. Then, there's this central block called attentive hybrid cost filtering, or AHCF, which aggregates features effectively using things like axial planar convolution and a disparity transformer. Finally, it predicts an initial disparity and refines it iteratively using GRU blocks to get the final, more accurate output disparity map. So it's this combination of the large FSD dataset and these architectural innovations that really pushes the zero-shot performance. Okay, so building on that architecture description, this next figure 3, digs a bit deeper into those specific components. On the left, it shows different design options they considered for that side tuning adapter, the STA, which brings in the knowledge from the Depth Anything V2 model. They found option C worked best. Then, the right side visually demonstrates the impact of both the STA and that attentive hybrid cost filtering, the AHCF. You can really see the difference. Like with the STA, it better handles tricky areas, like the lamp or the dark guitar hole. And with AHCF, it improves details over repetitive textures, like the pavement. It really shows how these modules help. Okay, so we've talked a lot about the FSD dataset and how its scale and diversity, along with the model's architecture, contribute to that strong zero-shot performance. This figure 4, gives us a visual taste of that FSD dataset. On the left, you see example images, some structured scenes, and some more randomized ones with complex objects, confirming the variety we discussed. But what's new here is on the right. It shows this self-curation process they use. It seems they automatically filter out ambiguous stereo pairs, like those with extreme texture repetition or difficult lighting, to further improve the dataset quality and the model's robustness. Alright, so following up on that FSD dataset quality, this table, Table 2, really quantifies that zero-shot performance we've been talking about. It compares FoundationStereo, listed as ours, against other state-of-the-art methods on several standard benchmarks like Middlebury and KITTI. The key thing here is that lower numbers mean better performance, less error. You can see two blocks. The top one shows models trained only on the older SceneFlow dataset, and even there, ours does better. But the bottom block, where FoundationStereo uses its full training data, including that massive FSD dataset, the improvement is huge. Look at Middlebury. Error drops from 7.5 for the next best method down to just 1.1 for FoundationStereo across all datasets shown, ETH3D, KIT-TI. It consistently sets a new state-of-the-art for zero-shot performance, really showing the power of that large-scale dataset and the architecture. Okay, so those quantitative results in the table really showed the numerical advantage. Now, this figure 5, gives us a more visual, qualitative comparison of that zero-shot performance on those tricky in-the-wild images we saw earlier. So the first column is the input image. Then we see the disparity maps predicted by several other methods. CROCO, CRE stereo, IGEV, selective IGEV, and finally, FoundationStereo, labeled WARS. You can see how the other methods sometimes struggle with reflections, repetitive textures like the tiles, or thin structures. FoundationStereo generally produces much cleaner and more plausible results, visually confirming that strong generalization capability we discussed. So, yeah, those visual comparisons really drive home the point. FoundationStereo shows truly impressive zero-shot performance, mainly driven by that massive FSD dataset and the model design. It significantly advances stereo matching without needing specific fine-tuning for every new scenario. This kind of foundation model approach, well, it's really paving the way for more robust and adaptable computer vision systems overall. Alright, that's all the time we have for today. Thanks for tuning in to the AI Research Roundup. I'm your host, Alex.